What's up, guys? Welcome back to the Math Club, and today we're going to be learning about the Pythagorean Theorem. So first off, the Pythagorean Theorem states that the square of the hypotenuse, which is the side opposite to the right angle, is equal to the sum of the squares of the two other sides. So the Pythagorean Theorem only works in right triangles. So let's make a triangle, a right triangle, and give it side lengths 3 and 4. So in the right corner, I'm going to write down the Pythagorean theorem, its equation, which is a squared plus b squared equals c squared. So what we have to do in this equation is substitute our side lengths into it. So we have side length 3, which we can put as a, and side length 4, which we can put as b. It doesn't really matter what side length you assign to each variable. You have to make sure that c is always the hypotenuse. So now we have to substitute a for 3 and b for 4. So we have 3 squared plus 4 squared equals c squared. So now we can just do basic algebra. We have 9 plus 16 equals c squared, and c squared equals 25. Now we have to get c by itself. So we know that c squared equals 25, and when you square something, the opposite of squaring is taking the square root. So what we have to do is take the square root of c squared and the square root of 25. So this becomes c equals 5. So now we know that our hypotenuse is 5. So the answer to these questions, it's not always going to be that nice of an answer. So sometimes you might get the square root of a number such as 8, which is not a perfect square, so it's going to be a decimal number. In those cases, I normally just leave it under the square root or simplify the square root if possible. So now I'm going to give you another triangle. This answer isn't going to have a nice number in it. My bad. Let's draw a nicer one. There we go. So we have a right triangle with side lengths 6 and 4. So we have A and B as our sides. So now we have to substitute in the equation, which is a squared plus b squared equals c squared. So a squared plus b squared, so we have 4 squared plus 6 squared equals c squared. So we have 16 plus 36 equals c squared. So now we have to do 16 plus 36, which we all know, 52, equals c squared. So we take the square root on both sides. So we get c equals the square root of 52. So 52 is not a very nice number, as you can see. So we're going to see if anything goes into that so we can simplify it, but we're not going to be able to get an integer number. It's going to be a number with the square root sign still over it. So we have 52, so that could be 2 and 26 or 4 and 13. So 4 times 13. So then that becomes the square root of 13, then 2, because we're taking this and square rooting it, and it's becoming 2. So we have the 2 root 13. And then this is its most basic form, its most basic answer. So we know that the hypotenuse is 2 root 13. Okay. So now I'm going to give you guys one to do. So I'm going to write the question on the board, then pause the video as as long as you need to, and then I'll solve the question right after. So we have the triangle. Very big triangle. 24 and 7 as our side lengths of A and B. So pause the video right now and solve. Okay, so what we need to do is a squared plus b squared equals c squared. 7 squared plus 24 squared equals c squared. So we know that 7 squared is 49 and 24 squared is 576. And that equals c squared. So what we have to do now is add these, and it becomes 625, which equals c squared. Then we have to do square root, and this becomes c equals 25. And that means we know that our hypotenuse is 25. So now I'm going to show you a different type of problem, different type of side that you can solve for. So we have the side, we have the triangle with the hypotenuse given to us. So we have 14 and 6. So in this case, our equation isn't this. Our equation is actually trying to solve for, let's make this the A and this the B, and then this is the C. So instead of a squared plus b squared equals c squared, we have to actually make it so c squared is on the left, and then we have to subtract b squared, and this equals a squared. You can basically see this as you're doing a normal equation, because if you subtract b squared on both sides, cancel that out, you only get a squared, as you can see here, and then you get c squared minus b squared, which is the new equation. And b squared and a squared can be substituted out either or. The sides, b and a, don't matter, but the hypotenuse itself does. So we know that c is 14 squared, so 14 squared minus 6 squared equals a squared. So we have 196 minus 36 equals a squared. So we know that this is 196 minus 36, which is 160, equals a squared. So we have to take the square root of 160, square root of 160, and then we get a equals the square root of 160. Then we can simplify this. So let's think of numbers. We have 1 and 160, 2 and 80, 3 and 50, nope we don't, 4 and 40, 4, 10. So 4 times 4 times 10. Out of this, we actually get 2 times 2 root 10, because the 4's, which is 16 times 10, is 4 root 10. So we know that our a term is 4 multiplied by the square root of 10. So thank you guys for watching. Make sure to like the video, subscribe to the channel, and just once more about the Pythagorean Theorem. Any of the a and b sides can be substituted either or. So you can label every side except the hypotenuse as either a or b. It doesn't really matter. But you have to make sure that you always make the hypotenuse the c term, and that there are different ways to find for different sides, like c squared minus b squared equals a squared, and c squared minus a squared equals b squared. And so once again, thank you guys for watching. Make sure to subscribe to the channel, like the video, and I hope you learned something from this video.